To determine the appropriate sample size to estimate either a population mean or a population proportion, that's important because it ensures that our estimate is accurate and reliable. And so we have two formulas to do that, and it involves these factors here. We have ZC, which is the critical value, or the Z-scores, which we'll refresh on that here in a minute. We also are going to be using p-hat, which is the estimated proportion of the sample. And then we have q-hat, which is the complement of p-hat, which is 1 minus p-hat. We have sigma, which is the population standard deviation, and then E is going to represent the margin of error. So we have here, this one here you'll see is if we're trying to determine the sample size for a proportion. This here we'll use as the formula for finding sample size when we're dealing with means. So I have two examples below here that we're going to walk through. Example 7 says a car dealership wants to estimate the average number of cars sold per month. So notice here it's talking about averages. Previous data indicates that the standard deviation of monthly sales is sigma is equal to 15. The dealership wants to be 95% confident that their estimate is within a margin of error of E is equal to 3 cars. And we need to find the sample size that we need in order to meet these conditions. So identifying what we need Z critical, which we get from the confidence level. We need sigma, which is given to us as 15. And we have the error, which is we want to be within 3 cars. And because we're talking about averages, we're going to use, let me highlight it, we're going to use this one up here. All right, so I have the sigma and the error. I just need to find the Z critical. That's our Z score for the desired confidence level. So our confidence level is 0.95. That says it right here. So go into GeoGebra, into the probability calculator, and choose normal distribution. Then if we want 95% to be in the center, that means there's going to be 5% left over. So in each wing, we're going to have 2.5%. So I want to figure out what's the cutoff for Z so that in between those Z's, and they should be exactly the same, just one negative and one positive because this is symmetric, I need to find what value Z is going to contain that 95% in the middle. So on GeoGebra, make sure that you put in, because we're doing the standard normal curve, your mean should be 0, your standard deviation should be equal to 1, and then on the probability, whoops, let me fix that. I meant to leave a blank there. I'm going to have a blank here, and then we want to put in 0.95 for our probability. And then when we put in 0.95, that will give us our value that's in the blank. What is that value so that anything greater than that value will give me 0.95? That will give me this cutoff point here. Then whatever that value is, this value over here will be the negative of that. Now, when you do this, you should find that that cutoff value, your Z-score, is 1.96 when we round to the nearest 100th. So now we have everything we need for this formula. I'm going to go back and erase this so I have some room. Okay, so we're using the formula that I highlighted up there in red, and we have n is equal to z critical, which is 1.96, times our sigma, which is 15, all divided by the error, which is 3, and I'm going to take that answer and square it. When you put that in on your calculator, you're going to get 96.04. Now, because we're doing sample size, and we want to make sure that we have enough members in that sample, whether it's number of objects or number of people, we don't want to ever round down when we're rounding. We always want to round up to make sure that we have enough members in that sample. So my final answer should be 97. We always want a whole number for our sample size because you don't want to have a half a member or a half a person, a half an object. You always want it to be a whole number. So just always round up to the nearest integer. So that's an example of using this formula here. And I knew to use that one because it was asking us to find the sample size for a confidence interval dealing with means. Now, if we're dealing with proportions, I'll use a different color here. We're going to use this formula. So in this example, it says a researcher is studying the proportion of popcorn kernels that pop when heated. The goal is to calculate the sample size needed to achieve a margin of error of 0.01. So I'm going to mark that down. Our error is 0.01. It goes on to tell us that our confidence level is going to be 0.95 for 95%. And we have two scenarios here, Part A and Part B. Part A is if you don't have information from a previous study to estimate your value of P. Going back up and looking here, it says if you don't have an estimated value of P, we're going to use 0.5 for P. Okay? So our formula is going to be z critical over the error, and we got to square that, times our P times our Q. Because if we're doing this without a preliminary study, then we have to assume that our P is 0.5, which means our Q will be 0.5. Because we're using the same confidence level as up here, we're using 95% confidence, so we know what that critical value is already. It's 1.96. So that saves us a little bit of work. But if that was a different confidence level, we would have to go into GeoGebra and work backwards to find that z-score. So we know that our critical value is 1.96 over our error, which we want is to be 0.01. We take all of that and we square it, and then our value of P is 0.5 because if we assume that we don't have any preliminary information, we're going to assume that P is 0.5 and Q is 0.5. Now, when you work on this calculation, you're going to end up getting, let's see, I'm going to put this in on my calculator, 1.96 divided by 0.01. I'm going to square that and then multiply it by 0.5 and then 0.5 again for the Q. And we get 9604. Now this one is nice, it came out even, so we don't have to worry about rounding up. But whenever you're rounding with sample size, to round it to the nearest integer, you have to round it up to make sure that we have enough members in that sample. Now for the second part, Part B, it says if we assume we do have information from a previous study, and we assume that P hat is 0.96, Then we can just plug in our information for P and then find the complement for Q. So in this case, if we have an estimate for P, we're going to do 1.96 over the error, which is 0.01, and square it. But now, because I know what P hat is, I'm going to put in 0.96 times, and then the complement, which would be 0.04. So this is my P, this is my Q, and then I'm going to put that in on the calculator, and I'm going to get 1444, let's see, 0.4416. And then I would round up to the nearest integer and say the final answer is 1445. So this is telling me if I wanted to estimate a proportion, I need at least 1,445 members in that sample size in order to meet the conditions of having an error of 0.01 and a 95% confidence interval. If I was just estimating what P was, then I would have to use 9,604 for my sample size to ensure that I'm going to have enough information to create this interval. And then the same thing up here for the example 7. If I wanted to have a confidence interval that's 95% confidence level, with an error, I want to be within 3 cars for my error, and I know that my standard deviation is 15, I would need 97 in the sample in order to find that confidence interval with those values. So, important to know, make sure when you're reading a question, it's asking you for the size of the sample. You want to make sure that you're distinguishing the difference between a mean and a proportion. If it's asking about finding a sample size for a proportion, you want to use the purple formula up here that I highlighted in purple. If you're estimating an interval and for a mean, then you want to use the formula that I have boxed in red.